Morning, everyone. Can you hear me? Hello. Are you able to see my screen? Yes. Good morning. Yes. Okay, let me start the session. Today we are going to discuss about the module 3, which is called as linear model for regression. Okay, can't hear you. Whether my voice is audible? Is this clear? Yes. Thank you. Thank you. Breaking. Please check your internet connection, right? I think from my side, I don't have any issue. Okay, so let me finish some of the topics or concept, and then I'll ask you if you have any queries, then we can discuss. Okay, so later on, I'll unmute you, everyone. Okay, yes. Shall I proceed? Yeah, thank you. Right. So moving on to the third module, which is called as linear model for regression, right? I hope you all aware in machine learning, there are 4 different types of learnings are available. One is supervised learning, unsupervised learning, semi-supervised learning, and then reinforcement learning concept, right? In the supervised learning concept, the difference between supervised and unsupervised learning is nothing but if you have a labeled data means both input and output should be available, right? In your data set, if both input and output is available, then we can consider that such types of data are labeled data with the help of y, that is with the help of target variable, right? With the help of target variable, I'm trying to I mean, with the help of this guidance, we are trying to make our mission to learn, or we make our model to learn the hidden pattern in the available or existing data set, right? But what suppose in some cases you will be having only input alone. There is no output at all, right? Without guidance, if your model is trying to identify the pattern, if your model is trying to do some task, then which is comes under unsupervised learning, right? In supervised learning, I can perform 2 tasks. The first task is regression, regression, and the second one is classification. Right? So in which case we are supposed to use the regression. See, the task is purely based on your target variable, the nature of the target variable, y, right? So if your target is, for example, if I ask you to predict the price, house price, based on the based on the square feet, number of rooms, whether it is whether the car parking is applicable or not, right? Based on these input features like x1, x2, x3, if I ask you to predict the target variable y, which is nothing but price, house price, right? Which is comes under regression concept. Why? Because the target values are nothing but a real continuous values, real continuous numerical value. For example, $1,100 and $900, $800. Likewise, you will be having some continuous real valued number. Hence, your task is going to be a regression, right? And what about classification? Based on the BMI and based on my, for example, the BP level and based on some H1BC, right? So based on such input information, if I ask you to predict or classify, if I ask you to predict whether the patient has diabetics or not, in this case, the outcome is only two. Either it could be yes or no, right? It is comes under categorical data. The target variable is categorical in nature. In that case, we are supposed to proceed with the classification approach or task, right? So what is our intention here? According to the module 2, our focus is only about regression. In the next class, we will move on to the classification task. Okay, classification task. Okay, right. So I'll try to finish up to this gradient descent, right? I requested the compensatory class for tomorrow's session, like from 1:30 to 3:30. Okay. once I got approval, let me post an announcement in the Taxila portal as well as in the Teams portal, so you can join. Right. Once you received an announcement, then only you have to join. Otherwise, I'll let you know the schedule later. Okay, because I didn't receive any confirmation yet. Once I got confirmation, I'll post an announcement. Okay. Yes. So what is linear regression? Before going to proceed with this actual machine learning algorithm, I just wanted to know you like about during your school days, you might have studied about the equation which is called as line equation. Yes, line equation. Yes or no? Thumbs up? No? Yes. What is that? Y is equal to mx plus c, right? Y is equal to mx plus c. See, try to connect the same equation with respect to our machine learning model, which is nothing but regression concept, right? Just assume you have square fit alone based on the single input information x1. If I ask you to predict the price, what is your y here? Price is your y, right? So what is our interest here? I'm trying to predict the price. I'm trying to predict the price. How do you predict it? Based on this line equation. I'll tell you why we are using linear line equation and all, right? Price is equal to m into what is your x? Square fit plus some constant value. What is m and what is c here? Yes, what is m and what is c? Slope and intercept, model parameters, slope and intercept. Okay, you have class between 2 to 4. MFML. Extra class or regular class? Extra. Oh, they already scheduled. This is for my section student or other class? Okay. Let me check. Okay. Otherwise, in the next week, I'll conduct the extra class. Okay. Right. What about weekdays? There are no sections. Wednesday, yeah, I will be available. Even Wednesday, Thursday also leave, right? Okay, we will discuss this later. Okay. Yes. So in this case, M and C are slope and intercept, right? M is nothing but slope. M is nothing but slope, and C is your intercept value, right? So I'll try to connect the dots with respect to linear regression concept, right? Before going to proceed with this regression algorithm, right? Regression model, right? The data should be linear in nature. I'll give you two examples or two images here. Let me know which one is linear. Yes, which one is linear? Left or right? Both are linear. Super. Both are linear. No left. Both are linear. That is, there is a relationship between x and y here. See here, there is a relationship between x-axis as well as the y-axis. X is your square fit and y is your price, right? We know that, right? If square fit increases, a price will also increase. So, are you able to identify the line? Are you able to identify the line, right? Between, I mean, we can plot the line in the data set. Yes? Yes. For this data also, we can plot some, there are multiple possibility, but we can draw a line equation. We can draw a line. So hence, such type of data are called as linear data. There is a relationship, linear relationship. If x increases, y can also increases. If x increases, y can decrease. There are two possibilities. The first scenario says, if square fit increases, obviously the price will also get increased. If study hours or if social media uh, a screening time, right? Screening time increases, then what will happen? Grade will reduce, right? There is a exact, I mean, it's not exact, there is a relationship between X and Y in this case. Yes or no, right? So hence, such approaches are called as linear data. So for linear data, we can adapt the linear regression. The main concept behind linear regression is if your data set is linear data, right? If your data set is linear data, you can use the linear regression concept. The thing is, the model will try to identify the best fitted line. Best fitted line. See, for this data, I can draw a line like this, or I can draw a line like this, or I can draw a line like this, or I can draw a line like this, right? How do I know? Okay, by observing the picture itself, let me know which line is best, whether line 1, line 2, line 3, line 4, line 5. Which line is best? I have data here. Yes, what is your answer? Line 3. Why line 3? Why line 3? Why can't be it's line 4 or 5? Okay, line 3 and line 4, we have to check. Okay, ignore line 4, less loss. The thing is, in simple, we are not discussing any mathematical concept and all, right? Nearest to the red line. No, all data points are, Anish, your answer is correct. But the thing is, all the data points are nearest to my red line. Yes? Yeah. So I can say that it's line 3 is the best. Based on without understanding any maths, I can say that line 3 is the best because um, line 3 is more aligned with my environment or data point. Yes, will you accept? Yes. Compared to line 1, line 2, line 4, line 5. Yes. Now, that is what your linear regression model will do. Even though for a single linear data set, I mean, your data set can be same, but the model should identify the best fitted line. There are multiple line equation is possible for your data set, but the model should identify the best fitted line. That is why we need a linear regression concept. Yes, up to this, any doubt? Up to this, any doubt? Shall I proceed further? Yes. Yes, thank you. So the next discussion is whatever we discussed so far is like provided as a template like, see, based on the target only, we can identify whether it is classification or regression. If it is a continuous real value number, then we are supposed to use the regression task. We are supposed to perform the regression task. If it is a categorical in nature, yes, no, maybe, or girl, female, male, female, or benign, malignant, or the flower type colors, red, blue, green. So if your target variable is categorical in nature, you can proceed with the classification approach, right? So I explained already with the help of house price prediction data set. This is another example using the sky, air temperature, air altitude, wind speed, and water and forecast. Based on that, we can predict the humidity. We can predict the humidity. Humidity is nothing but it's a real continuous number, right? Value number. So hence it is we are trying to proceed with the regression task here. Okay. What about this one? What about this one? Here I have two. There are two possibilities, right? We are trying to find out the model will try to learn a function that is f of x to predict y for a given x. Here y is a real value number. X1, Y1, X2, Y2, Xn, Y1. What is this? The given is only X1, Y1, meaning which you have only one dimension in your data set. That is year of number, year in number. And then what is your y? We are trying to predict the ice, Arctic sea ice extent, that level. Yes, we are trying to predict this ice extent value, right? Based on the year. Here I have only one dimension. Dimension means only one input. Hence, first record can be considered as x1. Second one can be, this is x1, this is x1, y1. This is x2, y2, x3, y3, up to how many records you have. For example, if you have 100 records, then it will be considered as x100, y100. That is what represented as a given input as a vector representation. x1, y1, x2, y2, up to x1, xn, yn. The model will try to identify the best function that is best fitted line to predict your y for a given x value. There are two possibilities. Either it could be a line equation or it could be a normal a smooth curve. Compared to red and green, red is a line equation. Yes, red is a line equation. The model tries to, model observed the best fitted line here. What about the green color? Green color is not, it's not a line. It's a smooth curve surface. It's a curve, right? There are two possibilities, but our focus is only about a line. Hence, it is called as linear regression, right? Linear regression. If your data are not, if it is not a linear data, then you are supposed to adapt to the non-linear procedure that we will discuss later. Okay? Yes. So initially, you will be having a training set. So the entire data can be considered as a capital D. Capital D. For example, if you have 10,000 records, 10K records in your data, entire data, right? Again, consider the the house price, square feet, as well as the price. Only two columns, only one input, and this is your output. Okay. Yes. So 10,000 records in your hand, which is nothing but D. Okay. So immediately you have to split the data for training purpose. 80% more oftenly, we will split the data for 80% for learning purpose, and for testing purpose, we will consider 20% of the data. That is 8K records allotted for training. For the training, both X and Y will be forwarded in the training set. This X and Y will be forwarded to the learning algorithm, passed to the learning algorithm by understanding both X and Y. Okay, if this is what my square foot, then this would be the Y pattern or Y value. Likewise, it will try to identify the hidden patterns. The model will try to learn the hidden patterns in the existing data by considering both target variable as well as input variable. Finally, it will come up with one function which is technically called as hypothesis function. Okay, hypothesis function. Once the learning is over, the model will give you one function, hypothesis function, right? So what the model will do? Okay, for this data, there are multiple lines we can plot it, right? Okay, so one such line, how do you write a line equation? If you have only one input, it's similar, right? Y is equal to mx plus c. Here I have only one input, I can use this equation, right? So the hypothesis function, after passing input, right? The model will try to identify, the model will learn the parameter. The observed parameters are, M is your intercept, sorry, M is your, this theta naught, this is your coefficient. This is a constant bias, right? This is nothing but a bias here. It's a bias value, constant value, or some default value should be there. And theta 1 is M or coefficient, slope or coefficient. That is how much important this particular input information is in order to predict my price value. That importance will be provided by the theta 1. The actual concept behind this is model will try to learn, model will come up with the best values of parameter. What is parameter here? Theta naught and theta 1. Theta naught is nothing but bias and theta 1 is your intercept, right? So I can assign both 0, 0, or I can assign both 1, 1, or I can assign 0.51. There are multiple values I can assign for this theta naught and theta 1, right? After assigning these values, the model will come up with, okay, this particular parameters are best, the parameters created the best fitted line for a given data. This is how the linear regression, this is the interpretation of linear regression concept. But how do I know? How the model will know which thetas are the best theta? That is what our next discussion. Okay. Before going to that, there are multiple regression models are available, right? One is simple linear regression and another one is multiple linear regression. If you have only one input, with the help of only one input, if you want to predict the output, then it is simple linear regression. Based on the square feet, if you are going to predict the price of the house, it's simple, right? Same scenario, I can consider square foot, prime rate, yes, residential or not, car parking is there or not, right? Likewise, I can have multiple input parameters, right? Based on such information also, I can predict the house price. So in this case, you will be having X1, X2, X3, X4. So multiple input features are, if you have multiple input features, based on the multiple input feature, if your model is trying to predict the income or, for example, price, hence it is called as multiple linear regression. Please remember the basic equation is y is equal to mx plus c, right? We are using y is equal to theta. The c is always theta naught plus, right like this, theta 1 x. If you have only one input feature, that is square feet alone, this can be written as price is equal to, how do you write it? Price is equal to theta naught plus theta 1 into square feet. That's it. Okay. But if you have multiple input features, how do you write it? Price is equal to, yes, what is that? Theta naught plus theta 1 into square feet plus theta 2. We should provide another weightage for the next variable, theta 2 into crime rate plus theta 3 into residential or not plus theta 4 into car parking or not, right? That's it. That's it. This is how we can create or make our equation. But it's a summation, right? It's a summation, right? So what I can do, I can simply use the formula. This is what my model. This is what my model, which is technically called as hypothesis for a given data, right? So which can be, it's a summation of all values. Summation of theta I xi. I can be starting from 0 to n. 0 to n, right? Theta I xi, which is equal to, which is technically called as because we are supposed to convert the entire data into a matrix format, then only we can utilize the matrix libraries available in the Python. So the general approach will be converted into a matrix concept. That is why the entire theta will be the all theta naught, theta 1, theta 2, theta 3, theta will be considered as a theta transpose x. This is what my final hypothesis, simplified hypothesis model. You can have n number of features, but the simplified version is this one, this equation. Yes. I stop here. Do you have any queries? Yes. Shall I proceed? Yes, yes. Thank you. Right. So the next important point is, how do I know which theta values are best theta value, right? How do you choose the theta value? How the model will work? What is the math behind the model, right? So that is what our next discussion, how learning the model parameters. There are two approach. One is closed form solution approach and another one is gradient descent approach. This is very, very interesting and important topic. Please pay attention for this class, right? Because for all, see, for linear regression, you will be getting theta as a model. For another algorithm, logistic regression, you will be getting different parameter. In other approaches, you will be getting different parameters. Each and every model, machine learning model will have their own parameters, but using gradient, this is the benchmarking optimization algorithm. Using this gradient descent approach, you can come up with the best parameter for your approach or model. Okay, so the base is similar, the approach is similar. You can utilize this gradient descent for all your machine learning algorithms. So please pay attention, okay? Because we are not going to explain the concept again and again with respect to logistic regression and other approaches, right? Yes. I'll start with the closed form solution. But before that, I'll give you the cost function. What is cost? Cost is nothing but error. Cost is nothing but error. Okay. Yes. Just ignore this. Now you have only y column. That is, you know for sure about the tip amount. Tip amount received. Okay. That is, for example, 5 rupees, 17 rupees, 11 rupees, 8 rupees, 14 rupees, 5 rupees. Likewise, you know for sure about only the tips amount. Okay. Yes. So here a basic model. A basic model can be average. I can take average of all such input, tip amount, right? So what is your then what is your hypothesis? H of x. H of x could be average of my y. Whatever is, because I have only y, right? Just take average of y. Whatever transaction is coming in near future, then for all transaction, for all bills, you just give the same tip amount, the average amount, right? This is one model, a basic model, right? So accordingly, the rupees 10 is the mean or average of this tip amount for meal 1, 2, 3, 4, 5, 6. We have 6, right? Up to 6. What suppose if I ask you to predict the tip amount for meal 7, then what the model will do? Because my average y-axis is tips, right? Average is, this is what my model, a linear model, the line. Able to see here, this is the best fitted line. Try to draw a perpendicular line from your input, right? The intersection point. Points, which value? It's 10, right? So for meal 7, you will be getting 10 as your tip amount. This is what model predicts here, because model assumed the average tip amount as a model, right? Model assumed this equation as a model. This is simple example. Try to understand. Okay. I'll give you one more example as well. Okay. Yes. Now, if what is your actual thing? What is your actual value? Actual y is this one, right? What your model predicts? What is your model prediction hypothesis is? Y hat. Irrespective of different transaction, irrespective of different meal, for all transaction, if you are going to evaluate for all the training point or testing point, right? What is your what your model will predict for meal 1? For meal 1, again, you just go and hit the line. Same. 10 only. Here also 10. 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 And for 7 also, you will be getting 10. Now, what is actual value? Actual tip amount received is 5. Actual tip amount received is 5. But model predicts, this is a predicted value. This is what my predicted value. The model prediction is, model predicts 10 as a result. What is the error? What would be the error? How much difference? That is error, right? Actual minus prediction. Actual minus prediction, which is nothing but 5 minus 10. You will be getting minus 5 as a error for the first data point. This is what technically error is nothing but residual here. Okay. Technically, we call it as residual, right? Moving on to the second data point, 17 minus 10. 17 minus 10, positive 7. That is what represented here for second data point. For third record, 11 minus 10 plus 1, right? And fourth record, 8 minus 10 minus 2 as your error for the fourth record. That is, it's not properly predicted. The difference is minus 2. 14 minus 10 plus 4. 5 minus 5, sorry, 5 minus 10 minus 5. This is what my error or residual for with respect to each and every data points. With respect to each and every data point. Okay, is this clear? But it's an error. Error is computed with respect to record, but I should compute it for the entire data. For entire data, if you are computing, which is called as cost function or loss function. Don't get confused. Both are similar. Both are same. The meaning of both cost function and loss function is same, right? So if you are considering error for single record, which is called as residual error or normal residual, okay? But what about cost function or loss function? For entire data, we are interested to find out the loss or interested to find out the error. Then how do you do it? Just add all the errors, sum of errors, what you will get? Because I have both positive and negative. So, actually, what is the what is the error here? Actual minus price. It's irrespective of considering the sign. We should know the difference between actual as well as price. So that is why we purposefully squared the error. Sum of squared error. First square the residual squared. 5 squared is 25, 7 squared is 49. Likewise, square all the errors, residuals, and then add, you will be getting 120. This is what sum of squared errors. This could be the cost function for this data. Yes. Now, in the same example, but what I have did here is I added one more column, right? My y is tip amount only. I just wanted to predict tip amount, but I have one input which is called as explanatory variable. This variable will explain how I can get the what is that? The target, the tip amount. Okay. Yes. Based on the bill, if I ask you to predict the model, see, if you have one input variable, what is your equation? I hope you all remember, right? Y is equal to theta naught plus theta 1 x, right? Just assume I have roughly given, it's a random number. This is a random number, right? The theta naught is 0.18188 and theta 1 value is 0.1462, right? So how do you write it? For this first record, I'll write only for first record, right? The record one can be represented as, I can predict the tip amount. Prediction can be written like this. Y hat, okay? Y hat can be predicted. That is, the prediction value can be theta naught. What is your theta naught? Theta naught? This equation, right? Or we can directly use 0.1462 into x minus, it's not plus, it could be anything. The value is, theta naught value is minus 0.8188. It's a dummy value. Please don't worry. I'll tell you how to get these values, right, in the upcoming slides, right? I just wanted to provide the notion of cost function alone. Okay. Yes. What is your first x value for residual one? For record one, x is 0.1462 into 34 minus 0.8188, right? Simplify this, you will be getting the predicted value, which is nothing but 4.1 for the first record, 14.9 for the second record, 8.5 for the third record. Likewise, you will be getting some predicted value after substituting x as such with respect to record. Now, how do you compute the error cost function? This is a record wise prediction, right? Compute the residual. How do you do it? Observed versus predicted. Actual is 5. 5 minus 4.1. You'll be getting some value, right? Value 1, right? And then 17 minus 14.9, you'll be getting value 2. 11 minus 8.5, you'll be getting value 3. 8 minus 12.04, you'll be getting value 4. 14 minus 13.65, you'll be getting some value 5. And 5 minus 6.6, you'll be getting value 6. Take a squared, that is V1 squared, V2 squared, and V6 squared, right? Add all together, you will be getting sum of squared error. Yes, is this clear? SSE. After that, you will be getting sum of squared error. Any doubt so far? I'll stop here. It's a random assumption. The theta, for this explanation, I assumed the random values. Okay? Yes. What is the purpose of mean? Yeah, I'll tell you. That is what our next discussion. Okay? Yes, y cap is predicted. Y is actual. Okay? Yes. So, the next discussion is, right, this is what your sum of squared error. Okay? See, sum of squared error we computed. But this 120 is not an actual loss, right? Because we have 100 records, or you can have 100 records or 10K records, or in this case, we have only 6 records. We need an average error for the entire. See, if you are considering one record, you can directly use the value as such. Okay. But whenever you are trying to consider for the entire data set, what I'm going to do here is, this is sum of squared. Yes or no? Will you accept this portion? Sum of squared. Why? See, one important point. It could be in some textbook, they can use actual minus predicted. That is y minus y hat. In some textbook, this is also correct. In some textbook, they can use y hat minus y. This is also correct because we are going to square the error anyway to avoid the negative signs. Okay. Yes, both are acceptable. So this is sum of squared error. Sum of squared error is available here. Then just leave this 2 here. You know, for the entire data, if you want the correct cost function, take a average. Take a average. That is mean. Okay. Take a average. That is why. That is why we are using 1 divided by total number of records. In this case, after adding the sum of squared error means you will be having capital V divided by n, you will be getting the cost function. As of now, you just ignore this 2, but in the formula, we are supposed to use 2. This is mandatory. This is very important. Don't forget. I'll tell you why we need to use in the next slide. Is this clear? Am I answer your question? Yes. So, see here, this is what our cost function of linear regression for the entire data. See, it's a mean squared error. We can say that, see, this is sum of squared, right? I'm just taking mean of for the entire thing. That is average. So, mean squared error. Okay, mean squared error is, that's it. Up to this. This is what your cost function. Especially you have a two-dimensional, this is a visual representation. And after plotting the prediction, okay, let me know in this graph, what is blue line represents, what is this blue points represents? Yes, blue line and blue points. What is blue line first? Blue line is, yes, perfect. Model predicted line, best fitted line. Model predicts this line is the best fitted line. Okay, yes. What is blue circles? Blue points? Yes, very good, Agarwal. Blue points are actual value, actual data in this case, right? Blue are actual data, actual input data. It could be x1, x2, x3, x4, right? This is my model prediction, that is h of theta hypothesis, right? H of theta, h theta of x for all x. Okay, this is what my line. Whatever point is here, that is what your prediction. Will you accept this? The greens are green color labels, or whatever I have used, whatever I have mentioned here, all are predicted. Yes, this is my prediction. Y hat prediction 1, Y hat prediction 2, Y hat prediction 3, Y hat prediction 4. The difference between actual minus, this is not only x, you'll be having y also. Please don't get confused. Okay, x1 comma y point, for all point you'll be having y also, right? Here parallelly, this is what my x, and you'll be having y, corresponding y. Yes, right. So this actual minus prediction is called as residual. This is residual error 1. The difference between these two is residual error 2. These two will be residual error 3, and these two will be residual error 4. Just add, square all the errors, add all together, take an average, you will be getting mean squared error. Yes, is this clear? The visual representation also I have covered. I hope, is this clear? Yes. Thank you. Right. So this is for two-dimension visualization. What suppose if you have 3 dimensions, right? So instead of calling line, you are supposed to use surface, right? I'm having square feet as one feature, and then crime rate as another feature. Based on these two feature, if I want to predict the price, then again it's like a line only, but it's technically we no longer use the terminology called line, best fitted line. It's a best fitted surface. Same. Otherwise, rest all other mathematical concepts. Are you able to see here? Actual point with respect to this point, the difference between these two is residual error. Rest all others are similar, right? So the concept behind the linear regression here is, this is what your error or cost function, loss function. The model will try to fit the best fitted line in such a way that model will try to identify the best parameters of theta so that the cost will be as much as minimum. That is the objective function here, as much as minimum. Okay, see here, what is my hypothesis? Hypothesis is nothing but for two-dimensional. Please assume two-dimensional. It's not two-dimensional. If you have only one input and output pair, yes, then theta naught plus, this is a bias term, plus theta 1 is for associated with respect to my single input square foot. Okay, and parameters are theta naught and theta 1, and cost function with respect to theta naught and theta 1 is 2 divided by 2m or n, and this is what your prediction. Okay, and the objective here is we want to minimize the cost function in such a way that the model should identify the best parameter theta naught and theta 1. Okay, theta naught and theta 1. Is this clear? Okay. For identifying the loss or cost function, let us assume your x is real value number. X is real. I have only one x, one input. It's a simple linear regression. Okay, x is real value number. So what your model would be? A model would be, what is your h theta of x? Model would be theta naught plus theta 1 x. Yes, what suppose if you have x1 comma x2, then your model would be theta naught plus theta 1 x1 plus theta 2 x2. These two are a coefficient of your input features. Okay, yes. Just assume we have a thetas, like in this model, I have theta naught and theta 1 alone, right? I have assigned in the first sample or first scenario 1, I randomly assigned theta 1 is equal to, sorry, theta naught is equal to 0 and theta 1 is equal to 1. Theta 1 is equal to 1. Then what is your hypothesis? Hypothesis of x will be theta 0 is 0, right? 0 plus 1 into x, which is nothing but hypothesis of x is nothing but x alone. Yes, will you accept? Are you able to connect the mathematical concept? Yes, shall I proceed? Yes, minimum of j gives the best parameter. Best parameter. If j is minimum, that parameter is considered as the best parameter. Yes, yes. So in this case, my hypothesis is nothing but, see, model is nothing but x. Whatever is x, your prediction is if your x is 2, then your y prediction will be 2. Same. Yes or no? That is the concept here, right? Yes, your y prediction is 2. That is the concept here. Yes. Now my x is 1. Then what is your prediction? This is what my best fitted line h theta of x. Are you able to see the concept or the point behind this? My x is 1 and according to my model, y is also 1. My x is 2, not y prediction. Okay. This is also 2 and my x is 3 and okay, like it's not y prediction, it's y only. It's y only, right? This is actual value. This is what your y prediction. Y1 hat, y2 hat, y3 hat. According to my model, the prediction is also 1 and my model actual value is also 1. according to the second record, the prediction is also 2 and the actual is also 2. And here the prediction is also 3 and actual value is also 3. How do you represent in a tabular structure? My x is 1, 2, 3. As per my record, actual y is also 1, 2, 3. Yes, but my model is also predicting correctly. 1, 2, 3. What is your error? Residual. What is your error? 1 minus 1, 0. 2 minus 2, 0. 3 minus 3, 0. Square it, 0 squared 0, 0 squared 0, 0 squared 0. Add it, you will be getting 0. 0 by 3, you will be getting 0. Sum of squared error, right? Mean squared error is also computed. Finally, you will be getting 0 as a error, cost function, right? For this parameter, theta naught and theta 1, which is nothing but 0, 1. For this parameter value, my error is 0. So that is what represented in the right hand side image. Are you able to see here? X-axis represents theta 1 value because theta naught is 0, right? So I ignore it. Theta 1 is 1. If you are considering theta 1 is 1, then your loss in the y-axis, I plotted the loss function or cost function with respect to theta 1, right? My cost function or error is 0, 0. That is why it is plotted here. Yes, any doubt in this plotting? No doubt, right? Shall I proceed? I'll go step by step. Ma'am, confusing. We are comparing y and y hat or y and x. No. Y and y hat only, not x. Yuvraj? Okay, I'll take one more scenario. No way. In real world data, there is no possibility to get 0 error. I'll explain the second graph with another scenario. Okay, don't worry. I have one more scenario also, right? This is what my second scenario here. Instead of using theta naught, see, in the first, what is our first scenario parameter? In scenario one, I used theta naught is equal to 0 and theta 1 is equal to 1. Yes, hence my hypothesis is nothing but it's simple x. I'm getting x. Whatever is input, same thing will be considered as a prediction. Okay, the prediction, y prediction. Okay, yes. In the second scenario, I'm using same value 0 for theta naught. Instead of 1, I'm using 0.5. 0.5. Okay, if you are using 0.5, then this is the plotted line. Model plots this would be, if your theta 1 is 0.5, this is the best fitted line. The model identified or model found this as a best fitted line. Okay, here see, listen, here my x values, for example, 1, 2, 3, 1, 2, 3. What is your actual y? It should be 1, 2, 3. It should be 1, 2, the actual value. It should be 1, 2, 3, right? According to this model prediction, how do you predict the model? Y prediction is equal to theta naught plus theta 1 into x. Yes, theta naught plus theta 1 into x. I know the theta naught is 0 plus theta 1 is now the value is 0.5 into x. Yes, so what you will get? What you will get as a y prediction for x is equal to 1. 0.5 into 1. Here, 0.5 into 2, 0.5 into 3. So, if for the first record, the prediction is, this is what the prediction. See, this x, see, please listen, this red color points are actual point, actual data. That is, if x is equal to 1, y is equal to 1. If x is equal to 2, y is equal to, actual is 2. If x is equal to 3, actual data is 3. Yes, this is what my actual point. But what is your prediction? Where you are supposed to plot the prediction? Try to draw a perpendicular line from here to this fitted line, right? The intersection point will tell you the prediction. Yes or no? This point, this blue color points are my prediction or y hat. Prediction or y hat. Y1 prediction, y2 prediction, y3 prediction. What is your y1, y2, y3? Just try to identify the y axis, which is nothing but 0.5. Are you able to see here? It's 0.5, which is nothing but 1. This is nothing but 1.5. 0.5, 1, 1.5. This is what my y hat. Then how do you compute the error? Errors are actual minus 1 minus 0.5, right? 2 minus 1, 3 minus 1.5 will be getting 0.5, 1, 1.5. Add. If you just see here, are you able to see here? This is, in this case, I used actual minus prediction, but as per the slide, it always uses the prediction minus actual. Okay. 0.5 minus 1 the whole squared plus 1 minus 2 the whole squared plus 1.5 minus 3 the whole squared. Simplify this. This 2 I will tell you later. Please don't worry. Right? What is this? 1 by n. How many records we have? 3 records. So take an average. After simplification, you will be getting the cost function as 0.58. According to the scenario 1, if my theta 1 is 1, the cost is 0. That is why I plotted here. Yes, this is about scenario 1. According to scenario 2, my theta 1 got assigned as 0.5. For this, your cost is also 0 or approximately 0.5. This is what your next cost. I'm trying to see with multiple theta parameters. I'm trying to identify the relationship between different theta values as well as the cost function. Is this clear now? Is this clear? Wait. I have not concluded yet. Yes, around 60% error. Up to this, no issues, right? Shall I proceed? Yes. So, the next discussion is, right, this is third scenario. What is third scenario? So, I don't want to explain in detail, right? By changing the different theta values, that is in the third scenario 3, see scenario 1, scenario 2, the theta 1 is theta naught, always theta naught is 0, right? Theta 1 alone, initially we considered 1, in the second scenario we considered 0.5, and in the third scenario we considered 0 again. For theta 1 is also 0. So in this case, what is your y prediction? Y prediction is hypothesis, right? Y prediction is nothing but hypothesis of input x, which is nothing but theta naught plus theta 1 x, because we have only one input, right? Substitute theta naught as 0, you'll be getting, and theta 1 as 1, you'll be getting x as a result. Yes, that is the prediction formula. And for scenario 2, for y prediction, same h theta of x is nothing but 0 plus 0.5 into x, right? That is half of x. Simple, half of x, right? 0.5 into x. And for the third scenario, what you will get? Y prediction is nothing but 0 plus 0 into x. What is 0 plus 0 into x? You will be getting 0 as a result. Right? Y prediction is always 0 for all input. Your x could be anything. 1, 2, 3, and actual y is 1, 2, 3. But your y prediction is always 0. For x is equal to 1, are you able to see the dark black line here? Yes, dark black line here. If your x is equal to 1, your y prediction is 0. Your x is equal to 2, your y prediction is here. If your x is equal to 3, your y prediction is y1 prediction, y2 prediction, y3. For all, it's 0. The difference between these are called as residual, right? That is 0 minus 1, that is 2 here, 3 here, square it, 1 squared, 2 squared, 4, 3 squared, square it, 1, 4, 9. In total, you will be getting 14 as a sum of squared error. So 1 divided by 2 into 3, the sum of values are 14 in this case. Just simplify this. 14 divided by 6, you will get some value, cost value, right? 14 divided by 6. So the cost is nothing but, what is this? 2.33. Okay. Cost is nothing but 2.33. For scenario 1, I got the cost error as 0. For the second scenario, different parameter value, I got 0.5 or 0.58 or 0.60, around 60% as my error. For the next 0 values, for these parameter, I'm getting cost value, error cost function is 2.33. It's not like a percentage. Please understand. Okay, it's not like a percentage. Compare the value, which is minimum. Which is minimum? What is our objective? We want to find the minimum cost function by fitting, right? We want to find the minimum cost function such a way, we want to find the best parameter such that it should minimize the cost. I have these many parameters. I have represented these 3 scenarios. Out of these 3, which one is the best? Which one is the best? Yes, Yuvraj, we are finding the local minima. Yes. Which one is the minimal? Scenario 1 or scenario 2 or scenario 3? Which parameters are best? 0.5, scenario 2. Yes, 0, 0.5 is the best parameter, right? By doing the manual steps, we observed this. Yes or no? We observed this. And one more important point, before going to proceed with this, you should understand the error or cost function. You should assume the cost function. Why we are considering this squared? Mean squared error is, it was proven, right? It was proven that it is convex in nature. It is convex. The cost function is convex in nature. This is, are you able to see here? It's a convex. The curve looks like a convex. The relationship between theta and the cost function looks like a convex point. Yes or no? Right? So, the point of C here, we are interested to find out the point of minima. Even though you have multiple loss function, this is the minimal point. This is point of minima or stationary point. So the requirement is, if you are in future, if you are trying to design a linear model, right? You have to, of course, you will get some cost function. You have to create a cost function in such a way that you should ensure cost function is convex in nature. Then only it can walk through it like this. It can search, okay, this is the best minimum value. Best minimum value. Why we are using MSC, mean squared error? Mean squared error, it has already proved to be convex in nature. That is why we are using mean squared error as a cost function, especially for linear regression, right? I hope I answered all your doubts, right? And one pending part is why we need this too. Yes, why we need this too, right? Right? I'll take one more slide. Yes. So why we need this 2, 1 by 2, 1 by n, up to this conceptually and logically it is correct. But why we need this 2? I hope you all remember this. See, this is for ease of elegance. Like in the differentiation process, if you are differentiating, for example, if you are differentiating x squared with respect to x, dou by dou x with respect to x. What is the answer? 2x. I hope you all remember the differentiation process. Yes? Okay. Instead of x squared, what suppose if I have passed the input as f of x, function of x? Because in the model we have function of x, right? In the model we have hypothesis is nothing but a function of x. It's a function of x. I think it's model will try to learn the function of f of x to predict the y, right? Instead of x, if I ask you to differentiate function of x, how do you differentiate? x the whole squared. In this case, how do you differentiate? Yes, answer me. In max, yes, perfect, Ganesh. It's a using ma'am, why S2 is best when S1 loss is 0? 1 second, 1 second. Let me check. Oh my God. It's not S2. Yeah, it's S1 only. Scenario is S1 only, not 0.5. Because our loss is 0. There it is. Yeah, first scenario. The best scenario is first value, please. It's my bad, sorry. The best values are 0, 1 because in that case only, in that model only, your error is 0. Thanks for notifying me. Yes. I guess no queries, right? Shall I proceed? Yeah. So in order to differentiate, I mean, okay, for differentiation purpose, if you are differentiating a direct x value, then it's totally different. Okay, we know the process. If you are trying to differentiate the function of x, then you are supposed to use the chain rule mechanism, right? Chain rule mechanism. Yeah, UV method, right? Chain rule mechanism. Okay. So what it will do? The 2 should be comes here. That is 2 into f of x. That is always if x power n is there, then n into x power n minus 1. That is the formula, right? So 2 into f of x into UV method. That is chain rule mechanism. You have to differentiate again with respect to x. This portion f of x. F of x. I'll give you one example so that it will be easy for you to understand the chain rule process. Okay. Yes. So differentiate dou by dou x. The function is nothing but 2x plus 3x squared, the whole squared. How do you do it? How do you differentiate it? 2 into 2x plus 3x squared, 2 into 2x plus 3x squared into dou by dou x. Again, you have to differentiate the function. Yes, which is nothing but 2x plus 3x squared. After simplification, what you will get? 2 into 2x plus 3x squared into, with respect to x only, you have to differentiate. You will be getting 2 plus 3x squared is 6x. This is the final answer. This is what your chain rule mechanism. Yes, got it? Yes. So why we are using 2 here? We know for sure the cost function is mean squared error. Here we have 2, right? So whenever we are trying to walk through from here to here, that approach is called as gradient descent approach. That is what our next discussion, right? So we want to walk through from any random position to in order to reach the minimum value, right? So how do you different? It's an iterative process. How do you reach from one oldest value to another new value? For that purpose, we are trying to differentiate the cost, differentiate the loss. Though differentiate loss function with respect to thetas, right? With respect to theta. Well, trying to differentiate the loss, this too will becomes here. It will come after differentiation. You will get 2 into the function, yes or no. And with respect to x, you will be getting x of I. I'll explain the mathematical part in the upcoming slides. Okay. So in order to ease of the simplification or computation part, purposefully I used this 2. This 2 and this 2 got cancelled. There is no impact. There is no that much significant in the value. There is no significant change in the value. So don't worry, right? For simplification purpose, to reduce the calculation purpose, we use the 1 by 2 here. Yes. Is this clear? Shall I proceed with one numerical example? The time. If you want to break, I can give 5 minutes break. Okay, in the gradient descent part, after completion of the mathematical approach of gradient descent, you will get the two, I mean, you will get the connect with between this two. Yes, don't worry. In the today class itself, I will finish gradient descent as well. Okay, just take 5 minutes break and then come back. Only 5 minutes. Shall we proceed? Yes, ma'am. Thank you. Chain rule, UV rule, it's see in your mathematics. I'm not supposed to explain with the example. Even I used it. It's you just refer your mathematics course in the you have parallelly you have foundational math, right? Some course, math related course, right? Yes. See, it's very simple. The thing is, we are using chain rule. I'll tell you the formula for chain rule alone so that it will be easy for you to understand. Um, the thing is like, 1 second. The formula alone. Okay. This is another, see here, the formula is just assume if you have u, right? If you have u, which is nothing but 2x plus 3x squared, hence your f of x is u squared. If I ask you to differentiate the function of x to u squared by dx, if it is a direct x value, no issue. But if it is a function of x, what you are supposed to do, 2u into differentiate the u, that is function with respect to x. That is what done here. Okay. This is for your reference. I added extra slide. Okay. Yes. And what about the next one? Next discussion, like the notion of maxima and minima of function. Okay. The notion of maxima or minima of function, which is nothing but, especially in the model, what is the role of maxima and minima? That is what our next discussion. Okay. Yes. Okay. So the thing is, see, if you want to find the minima, see, this is the minimal point, right? Point of minima. This is point of maxima. If you want to find out the maxima with respect to your project or problem statement, if you want to find maxima, either maxima or minima, just differentiate the x value. Just differentiate the x value. Differentiation is nothing but if you want to find out the minima for this point, for this location, for this region, or for this curve, right? Compute the tan theta. Compute the tan theta with respect to, see, take the target, take the target parallel to this line. Take the target parallel to this line, and parallel to this axis, and find out the tan theta, which is equal to and equate to 0. Tan theta should be equate to 0, right? Tan theta can be represented in different way, which is nothing but the differentiation of curve. If you are trying to differentiate this curve, right? If you are trying to differentiate this curve means the function, right? Right? You will be getting the tan theta angle, which can be equivalent to, which can be equated to 0. Here the theta is the parameter. Please listen, theta is the parameter, not an angle. Theta is a parameter, not an angle, right? So this is how This is how the maxima or minima will help you to identify the the best values, right? And one more important point, there is a possibility you may stuck into local minima. See, okay, if you have a curve like this, if you have a curve like this, right? If you have a curve like this, how many local minimas and how many minimas are there? Minima. This point 1, 2, 3, 4. This is minima, right? Minima point, minima point. There are multiple minima points. You can have multiple local minima, but out of this, you should have only one global minima. This point is the global minima. Yes. Similarly, you can have a multiple maxima. This is one maxima. This point could be one of the maxima point, and this could be another maxima point. This could be another maxima point. This could be another maxima point. But out of this, except this is your global maxima. Rest all others are local maxima. But don't worry, we are using the cost function, especially for regression. We are using what is that? Root mean squared error as a cost function. It has been explicitly proved that it is convex in nature. So you don't need to worry about the local minima. At one point in time, you will end up with the minima value, right? So don't worry about that. But in real time, in some cases, you can stack up with the local minima point. So in the next semester, I guess you will be having some courses called ACI, Artificial and Computational Intelligence course. There you can find out one interesting topic called if the model is stuck in the local minima, how do you get it? How do you get or how do you come out of the local minima point, right? How do you reach the global minima or global maxima? So there are some optimization algorithms are there. Always hill climbing will stuck into a local minima. So in order to overcome that scenario or situation, you can take random restart or stochastic hill climbing algorithm, even genetic algorithm, and colony optimization. This is another interesting topic that will be covered in your next semester. Okay. So, and this is again the notion of maxima or minima, right? So here I have mileage as my input and car price as my output. If you want to predict the car price, there are multiple scenarios. Model 1, model 2, model 3. My theta naught is always 1 for all model. For theta 1 is 0.05, 0.25 and 0.75. After substituting this x value in each and every model representation, you will be getting error, right? Sum of error, sum of absolute error. Sum of absolute error means like instead of taking square error, 5 minus 10, take absolute. You will be getting, instead of minus 5, you will be getting 5. That is absolute error, right? So take the error and add all together. Finally, you can take an average. For model 1, this is your error. Okay, first function. Model 2, this is your, if you are increasing your theta 1 from 0.05 to 0.25, you will be getting 12.4. Okay. Again, I just wanted to increase more, 0.75. Suddenly, the loss got increased. Right? We know for sure the loss function is convex in nature. That is why we always select this as a best result. Right? This is the point of minima. Right? See, I'll explain the concept, the gradient descent convex concept in the pictorial way, using visual representation. Always consider it's a 3-dimension. It's a 3-dimension. You have x and y values. Right? So here I have used y is equal to theta 1 x1 plus theta 2 x2 plus theta naught. Theta naught is 1. So I don't want to consider here. Yes. This is what your theta 1. And this direction, this angle is your, axis is your theta 2. And this is your cost function associated with respect to theta 1 and theta 2 value. Okay. So from here, from the top, try to see the bottom, the least bottom, the minimal bottom, right? This is what the bottom here. Yes, this is what the bottom position, right? See here, at this moment or at this area, your loss will be minimal. Your loss will be minimal, right? I'll consider this as one contour. Yes, I can also consider this is one region, like one region. Okay, I can consider another region. Whatever data points belongs to this region, then you can have another cost function like this, right? I can also have one more. I'll draw one more contour, third contour, fourth contour, right? Likewise, I can draw it, right? So what you will have for the third one, you'll be having this error, this cost function. Fourth one, this, and the fifth one, this is the cost. What is your interpretation? Innermost circle. For innermost circle, the cost is relatively small compared to other circles. So what is your objective? You want to reach this innermost circle. That is called gradient descent approach. Okay. So initially, you can see the gradient descent approach initially starts with any random point. There is no need to assign purposefully, right? There is no need. Okay. So what will happen? It will randomly, just assume it will randomly starts here. Okay. After differentiating, that is taking tan theta, and tan theta is nothing but taking differentiation with respect to loss, right? After differentiation, then it will walk through like this. It will walk through like this. Okay. And from you'll be getting some updated value. That is, my loss is reduced from here to here. Yes. Yes. From here to here. And then again differentiate the loss. Then you can reach here. The next jump. 1, 2. And then you can reach here. The next jump. Right. At one point in time, you will end up with the least cost. That is why we are expecting convex function in the loss function, because the mandatory thing is we need to differentiate the loss function in order to get the minimal loss, the best parameters. That is the concept behind the gradient descent. That is what represented here. See here. So from here, what you can do? You can go like here to here, here to here. Our objective is we want to reach this position. The loss should be minimal. And the next approach is closed form solution. See, okay, I don't want to do any iterative method, right? But I want to do using some mathematical approach. I don't need any iterative method. I don't want to consider any like random values and all, right? In that case, how do you find the best theta parameter? So for that, you should understand the vectorization concept. This is what your data set. You have only one dimension, number of years of experience, right? Years of experience, which is nothing but x1, and this is your y. How do you represent this hypothesis? If you have only one, then it should be theta naught plus theta 1 x. That is number of years. So along with this number of years, if I have added some more features, for example, x2 and x3, number of experience, year of experience, and for example, skill and qualification, skill and qualification. If I added two more input information, then your hypothesis will be theta naught plus theta 1 number of years of experience plus theta 2 into skill plus theta 3 into qualification. What is your h of x? The y prediction. Y prediction is nothing but I just wanted to predict the salary, right? Now, it's a simple summation. So I can use summation. So this can be theta I all inputs can be x, right? Xi, right? I can be, or j, in this case, they are using j. I, x, theta j, xj. J can be starting from 0 to 1, right? If it is 0, what will happen? Substitute it, what will happen? Theta 0, x0 plus theta 1, x1 plus theta 2, x2. That is what represented here, right? Yes. So in order to maintain this x naught value, always I used one add-on or additional parameter, which is called as x naught is nothing but always you should consider for all the record. This is x1, this is x2, this is x3. For all the records, your x naught should be always 1. Please remember, right? Don't forget, right? So always your x naught should be 1. In this case, it's my data set is very simple, right? How do you represent this? How do you, so see, if you are trying to convert the entire information into a matrix format, then you can utilize the Python matrix libraries and you can compute it. That is what our closed form solution. So the benefit of vectorization is it's more compact equation. You can do a faster code because using optimized matrix libraries, right? So consider this, this is our model. For this model, what would be a theta? Starting from theta naught to how many dimensions you have? For that time, that much thetas you should have. And x transpose is nothing but, x is nothing but your input variable. In this case, I have only one, that is number of experience. There is a possibility you can have more number of dimensions. So x1 to x dimension, d dimension, but this one represents x naught always. Okay. So for this model, for this data set, actual data set, the vectorized form of hypothesis of for a given information, given input information is theta transpose x. What is theta transpose x? Which is nothing but y prediction is nothing but h theta of x. H theta of x is nothing but summation of theta j x j. J is equal to 1 to n, 1 to d. And this can be rewritten like this as a matrix representation, theta transpose into x. It's a matrix multiplication. So in this, for this data record or data set, by considering only two columns, my thetas are, right, only two, theta naught and theta 1. Yes, this is what my matrix. And what is your x transpose? X transpose is, x value is nothing but 1, 2, 3, 4, 5. That is what my x, 1, and x naught will be 1, 1, 1, 1, 1. Likewise, you have to write. See, that is what represented here. Actual theta naught is theta naught. Theta matrix is, theta vector is theta naught, theta 1. What is your actual x here? 1, 2, 3, 4, 5. For all records, I should maintain x naught as 1. Okay. And what is my y? 2, 3, 4, 5, 6. Now you can do the transpose function. Okay. What we are going to do here is, so after simplification, this is what your cost function 1 divided by 2n summation of all sum of squared error, right? The hypothesis can be rewritten as a theta transpose x power I. Yes or no? Yes. Hypothesis can be rewritten. That is what we discussed here, right? Theta transpose, yes. Okay. Minus yi the whole squared, right? See, the entire thing can be, just assume the entire thing is represented as a. Then how do you split it? A squared. This is a squared, right? I can rewrite a squared as a dot a. Will you accept? That is what I written here. Yes or no? Yes. Theta naught x into theta minus y, x into theta minus y the whole transpose. Don't worry about this. It's a simplification. There is a proof, right? Right? After simplification, what you will get? After simplification, what you will get at the end? See here. Theta transpose. This is what x theta minus y the whole transpose, right? Into x theta minus y. This is one a and another one a dot a is, which is nothing but a squared. I'm just using the transpose according to this theta transpose, right? Yes. Then simplify this, you will be getting this expression, Now you just take a derivative of this expression, derivative of theta with respect to theta transpose, x transpose, x theta minus 2 theta transpose, x transpose y plus y transpose y. You will be, initially you will be getting y transpose y and equate to 0, right? After differentiation, what you will get? This should be with respect to theta transpose, right? X transpose x into theta, right? Here, x transpose y. Here you will be getting x transpose y, which is equal to 0. Finally, after simplification, x transpose x theta is equal to x transpose x. So how do you compute the theta value? Theta can be x transpose x whole inverse. This is comes here, right? Whole inverse x transpose y. In the closed form solution, don't worry, they won't ask the proof, right? They will give you the theta value, x value, y value. You are supposed to identify the best parameter theta. So the final formula here is x transpose x, the whole inverse, into x transpose y. If time permits, at the end, I will explain the proof, but it will take more time. Okay. After simplification, you will be getting this formula. So using the closed form solution, yes, using the closed form solution, uh, if you want to identify the best theta for a given problem statement, you can use this formula. So don't worry, I'll directly proceed with the, what is that? Problem statement, one numerical problem, so that it will be easy for you to understand. Okay. So same. This is what my x, x1, y. Then what would be your x naught? X naught will be, see, x naught, x1. 1, 1, 1, 1, 1. Yes, this is what your actual x. Yes or no? Actual x. Yes, actual x. And if you are transposing x, then what you will get? If you are transposing x, you will, in the matrix, according to the matrix, you have to transpose, right? If this is what you are, what is the formula? X transpose x the whole inverse. Please note it down. X transpose x whole inverse into x transpose into y. That is the formula, x transpose into y. We know the x transpose value. After transposing this, the vertical will be converted into horizontal matrix, right? 1, 1, 1, 1, 1, 2, 3, 4, 5. This is what my x transpose into x. What is your x? Actual 1, 1, 1, 1, 2, 3, 4, 5. This is what your x. Whole transpose, whole inverse. It's not transpose, inverse. Whole inverse into x transpose, that is actual x transpose into your y. Y is 2, 3, 4, 5, 6, right? So this is a matrix representation, right? First do the multiplication with x transpose into x, right? Or x transpose into x, and then later on, first do the multiplication, x transpose into x, right? You will be getting 5, 15, 15, 55, 5, 15, 15, 55, and then take inverse part, and parallelly, you can also multiply with x transpose into y, okay? And after taking inverse, what you will get? 1.1 minus 0.3 minus 0.3 minus 0.1 into x transpose into y. These values are there. And then multiply with this, you'll be getting this expression, these values, and then multiply with the y, Finally, you will get only two values, which is nothing but 1, 1. Always the first value represents theta naught, and the second value represents theta 1. Based on the data set, based on the dimension, you will be getting the number of theta using the closed form solution, right? So I'll give you this as a homework because it's a matrix multiplication and inverse only. Matrix multiplication and inverse only. Yes. No. Matrix concept is base concept. You have to do a self-read. Okay. If you want, I'll give my annotated slide. Give my annotated slide. Okay. It's simple matrix multiplication, right? There is a possibility they can ask the question to do it, either using closed form solution or ordinary least square method, right? No need to use gradient descent. This is the final. Using a closed form solution. Sine wave. No, that is Himani Agarwal. That is totally different. That is gradient descent. That is gradient descent. Okay. This approach is closed form solution. I can't explain the closed form solution using the wave concept. This is closed total. There are two approaches. One is you can get the best parameter using closed form solution, only one iteration. That's it, right? At the end, after doing this matrix multiplication and inverse process, you will get final best theta values, final best theta values. But in the next gradient approach it's a iterative process. Iterative process. That is second approach. That we will discuss later, Venkatramana. First, let me explain the both approach and we can compare both. Yeah, for better, for matrix, you can use you can refer. Okay. What is this? Thank you. A transpose, A inverse. Yes. In a closed form solution, in a single go, you can get the solution. Few slides back. Which slide? See, read the matrix operations. Just as a refresh. You know all the process, right? Just refresh the matrix manipulation or operation. Just implement here. You will get in a single slide itself. You can get it. A single page after implementing or after solving a single page itself. You can get it. This one or which slide? Yeah, that is what our next discussion. If we have huge data, this is not feasible. Himani, shall I proceed? See, MSC is, Amit, don't get confused. MST is loss function. That is mean squared error. GD will help you to identify the best theta. Don't connect MSC and GD. You can compare gradient descent with closed form solution. Don't compare with MSC with the gradients. Totally logically, it's irrelevant. You can compare gradient descent with closed form solution. For both the approach, the loss function is same, mean squared error. Okay? Yes. So please understand, initially you will be having some data, right? If you have minimal features, if your dimension of the data is minimal, you can use closed form solution. You can use closed form solution. What is the meaning? It's a matrix representation. It's a matrix representation. Don't worry about the proof. As per the matrix vectorization formula, right? If you want to identify the best theta value, if you have two dimensions in your data, what is two dimension data? You'll be having x1, x2, and one target variable. If you have one dimension data, you'll be having x1 and y alone. If you have two dimensional data, then according to the closed form solution, at the end, you will be getting three values. Theta naught, theta 1, theta 2. This theta naught is bias term. Theta 1 is associated with x1. Theta 2 is associated with x2. If you have only one dimensional, at the end of the closed form solution, you will be getting two thetas. Theta naught and theta 1. Theta naught is bias, right? And theta 1 is associated with x1. What suppose if you have square feet, number of bedrooms, crime rate, and price? Then how many thetas you will get after solving using closed form solution? Your theta will be theta naught, theta 1, theta 2, theta 3. The theta naught is associated with bias and theta 1 is associated with square feet. Theta 2 is for a number of bedrooms and theta 3 is for crime rate. Is this clear? Is this clear? Using the formula x transpose into x whole inverse. First, transpose is different. It's very simple. If you have 1, 2, 3, 1, 2, 2, 1, 2, 3. Okay, 1, 2, 3. Okay. If you have a matrix like this, 1, 1, 1, 2, 2, 2, 3. If you are transposing this, you will get 1, 1, 1, 2, 2, 3. This is what x transpose. And using the multiplication, matrix multiplication concept, you just do the multiplication and try to understand the inverse concept, A inverse. How do you get the A inverse? That is, find the determinant, and based on the coefficient, you just change the sign. That is a process. Please read and try to do it. It's very simple base maths, right? Try to do it. And then the rest all is a simple matrix multiplication only. Try to solve this problem by using pen and paper. Come up with a solution, whether are you able to reach this theta or not. 1, 1 at the end. Okay. The next class, if you are not able to reach this 1, 1, then I'll explain again. Please post the solution in the Teams. I'll explain. Okay. Yes. So this closed form solution is used whenever you have a minimal dimension. That is, for a small data set, if you have 2 or 3 or 4 dimension, then that is fine. Okay, even for that also, it's computationally it's not cost effective. The computationally it take so much of time. Okay, because you have to do the transpose function as well as the inverse function, and you have to do the matrix multiplication. It's a heavy computation, right? If your number of dimension is larger in nature, then closed form solution will not work. It will give you the answer, but it will take more time. Computational is more time. Okay. But what is the next approach? What is the best approach? Instead of using the matrix multiplication concept and all, what I can do? I can use the gradient. Gradient is taking tangent of theta. What is this? It's nothing but differentiation. Differentiation of loss with respect to theta. Whenever you have in the first iteration, if you have one loss, right? Differentiate the loss. You can update the different theta parameter values. Okay, I'll explain with the visual representation so that you can easily get the you can connect the dots. Okay, this is what my first scenario in the gradient descent. What I'm going to do, it's an iterative process. Remember this. It's an iteration one. Okay. I have only one data, that is x1 square feet and then price. Okay. Initially, as per the gradient, it randomly assigns the theta value. How many thetas we need here? Theta naught and theta 1. Yes. So what is your theta naught? Theta naught is minus, according to this, minus 900. Yes. Minus 900. And theta 1 is 0.1. 0.1, right? So these all are my training data. Using this hypothesis, model observed this as a fitted line, not best fitted line. Okay, model observed for this theta naught and theta 1 value, model observed this as the prediction line. Okay. Now, immediately try to plot this information with respect to theta naught value and theta 1 value. What is your theta naught? It is 900, right? Around 900, around 900, around 900, and theta 1 is minus, sorry, it's plus, okay, minus 0.1. For this, your loss is, this is what your loss. This is what your loss. Okay. Okay. After in the next iteration, I'm just changing my theta values. Changing my theta values, right? So initially, if it is 1900 and I'm just changing, updating my theta value, again, I'm getting around minus this minus 1.1. But from here, from this contour, I jumped to the previous innermost circle, right? So we know for sure in the in the innermost circle only we will be getting the minimal loss. The outermost circles are relatively higher, right? We want to jump from here to here, here to here, here to here, here to here, and here to here. Our objective is the model needs to reach this position, right? So by adjusting the theta values in each and every iteration, right? After in the next iteration, see here, I'm just changing my theta naught as well as the theta 1, right? So I'm just moving here. And then, see, are you able to see here? The line is also moved from here to here, here to here. Yes, keep on do the same process again and again after adjusting. See, updating the theta value and theta 1. How do I know? How do you update it? Using the differentiation function, right? Using the differentiation function, you can update the theta values. And at one point in time, are you able to see here? From here, the model is trying to reach the innermost core, the lowest cost, right? It's an iterative process at one. See, do the process again and again. In the next, at the end, the model reaches this position. Whatever is observed as theta naught and whatever is observed as theta 1, that is the best parameter using gradient descent. This is the visual representation of your gradient descent. Is this clear? I'll explain the mathematical approach. Yes, the mathematical concept will be explained within 2 minutes. Yes, linear algorithm automatically see linear regression itself. I mean, it adapts the gradient descent approach. That is why you are getting the best fitted line at the end. I mean, whether the webinar is over. Yes, we are trying to converge the theta values. But the stopping criteria here, it can be like here it can be, you can stop, if your loss is 0, you can stop. Yes, that is the first criteria, stopping criteria. The second criteria would be, you can fix the number of iterations or epochs. 10,000 epochs. There is a possibility the algorithm can converge, right? And the third possibility is, what suppose if like you're in 500 and okay, 501 iteration, and you can compare the previous iteration, 500 iteration. Okay. Yes. Compare these two. You can fix some threshold. You can fix some threshold for loss. If the difference between this iteration and this iteration is 0.0000, that is e power some minus 20 or some minus 3 or minus 4. Likewise, if you are giving, if the difference is very, very minimal, you can stop the algorithm. There is a possibility. These all are the stopping criteria. But the most important parameter in the gradient descent is step function or learning rate. Learning rate. See, from here, I mean, how do I know how the model or how the gradient descent will know who is controlling the the flow of jumps, right? Whether I can jump from here, see, it's very simple. I can jump from here to here like this, a very, very small jumps. Or I can jump from here to here, or here to here, or here to here. The jumps are very large, right? The variation is large. Who is going to control this? The learning factor or the learning rate will control this value. Okay. In each and every iteration. Always in gradient descent, initialize the theta value, repeat until convergence. This is the weight update formula. You know, you asked, right? How the weights are getting updated, right? The theta j is always new, which represents the new weight. New weight can be computed, right? Uh, take the old weight, minus alpha is nothing but your learning rate. I know just now I explained, right? Learning rate is which controls the jumps, which controls the gradients. Okay. Alpha is a learning rate, right? For example, here I fixed 0.05, right? And the next thing is after computing the loss, J theta is nothing but loss, right? Loss of one model. Differentiate the loss with respect to theta. That's it. Then you will get, simplify the formula, simplify the values, you will get the updated theta. In the next iteration, updated theta should be considered for as in the hypothesis. Okay. Then again compute the prediction, compute the loss, you can get the final result, right? So this is how the model will go here. This is how the model will proceed. The mathematical approach will go, right? So how do you differentiate the loss function? Differentiate with respect to theta. What is my loss for linear regression? It's a sum of squared error, mean squared error, right? 1 by 2n summation of h theta of xi is nothing but my y prediction. Yes or no? Hypothesis, y prediction minus actual value. The difference between these two, take squared for all the records, for all the features, right? And take an average value and you just keep 2 here, right? This is mean squared error, right? Yes. After differentiation, what you will get? And this can be rewritten like this also. We know for sure as per the vectorization, right? Hypothesis of x of I can be theta k xk of I. Theta into xi. Theta into xi. Yes. So that is what represented here. Theta into xi minus yi the whole squared. Yi the whole squared. This is with respect to k is with respect to based on the number of dimension. Based on the number of dimension, you are supposed to consider this for all records. N is nothing but my records. Okay. And after that, after differentiation, what you will get? This 2 will come here, right? It's a function. The entire thing is function. So 2 divided by 2n. You will be getting 2 divided by 2n. This 2 and this 2 will get cancelled. Finally, you will be getting 1 by n. 1 by n. With respect to theta only, I am trying to differentiate, right? So this portion will be represented as such as per the UV or chain rule mechanism. And again, you have to differentiate the same function. This is, for example, if you have f of x the whole squared, if you are trying to differentiate with respect to x, this will be 2f of x. That is what represented here, right? 2f of x into d by dx with respect to f of x. Again, you have to differentiate with f of x, right? Yes. After that, what you will get from this point where you have theta, only this element has theta. Differentiate with respect to theta, you'll be having only xi. That's it. That is what x value here. Yes, this is the final update after differentiation. The differentiation of theta, j theta, cos function is nothing but this formula. This formula, right? Initialize the theta, repeat until convergence, bold theta value minus learning rate divided by 1 by n, because this is what my theta. I mean, differentiation of cos function. 1 by n summation of I is equal to n, hypothesis of xi minus yi into xj of I, right? I'll skip all these slides. Don't worry. I'll revisit the slide. Okay. Take this numerical example so that it will be easy for you to understand. Easy for you to understand. Okay. Yes. According to this problem statement, What is this? Number of instances and two predictors. That is x1, x2. It's a linear regression. The equation would be y is equal to w naught w1 into x1, w2, x2. Cos function of derivative. Cos function and derivative function could be w naught. New w naught value will be old w naught minus this dash is new minus 1 by n into learning rate. Learning rate, okay, I'll take here. Okay. What is this? Just read the problem statement. Fit a linear regression. Show only the first iteration of gradient descent. Only one iteration. In exam also, they will ask maximum of 1 or 2 iteration based on the number of records. Okay. First iteration of gradient descent algorithm using learning rate 0.02. The alpha is 0.02 for the following data. That is, that we have some 3 patient records: systolic pressure, diastolic pressure, BMI, and waist circumference, and RD, chronic disease, relative risk of coronary heart disease. This is what my prediction. This is what my prediction. I want to predict this. Okay. But here, I'm not going to consider all the input feature. I'll consider only if the relative risk of coronary heart disease is believed to be only linearly dependent on BMI as well as diastolic pressure. I will consider only these two as my input, x1 and x2. Assume the intercept of the regression model. Intercept of regression model will be 5, and the slope of the independent variables, whatever variable you have for all variables, it will be minus 0.03. If you have only 2 input features, how do you, what is your prediction? Y is equal to theta naught plus theta 1 into x1 plus theta 2 into x2. What is your theta naught? Biases? Sorry, biases, where is bias? Intercept, yeah. Intercept is 5, right? Intercept is 5. This is 5 plus theta 1. Whatever variable you have, for that slope will be minus 0.03 into diastolic pressure plus minus 0.03 into BMI. This is how you can predict the Y. This is what my model. Is this clear? Is this clear? Yes. So the identification of equation would be like this. Instead of theta, I used weights. I'm trying to update the weight here. Okay. So don't consider these two. This is your x1 and this is your x2. So in order to predict the RRCHT, the final equation would be look like this. And the prediction is after substitution, what you will get? Minus after substituting W0, W1, W2, you will get this equation. Is this clear? Yes. Step 2 is weight update. Weight update, how do you compute the weights? Before that, as per the model, this is what my x1, x2, my actual y is like this, right? Using this, first, see, I'm just trying to calculate this portion, 0.03 into x1. What is this? 0.03 into 35. This is 0.03 into 25. 0.03 into 30. And what about this one? Taking x2, second feature, 0.03 into 80, 0.03 into 80, 0.03 into 100. After simplification, you will be getting this portion and this portion. Substitute in the equation 5 minus this portion minus this component, right? So 5 minus, this is 1.05 minus this value, which is nothing but 2.40. After simplification, you will be getting 1.5 as a prediction, 1.85 for second record prediction, 1.10 as a third record prediction, right? Compute the error, residuals, actual minus prediction or prediction minus actual. 1.55 minus my actual is 1.81. The error for the first record is minus 0.26. For the second record plus 0.63, and the third one is like this. This is what your error. Okay. Once you have computed the error for each and every record, this is what my error, right? Summation of all errors. Summation of all errors. Just add all together. Just add all together. Yes. Just add all together. minus 0.26 plus 0.63 plus minus 0.63, add all together, you will be getting some value. That is 0.024, right? And one more important point, in the problem statement, if they are explicitly asked you to take root, mean squared error, then you have to square this value, add this value, and divide 1 by n. The formula, you know the formula, right? For simplicity, I am not going to consider anything here. I'll just add all the errors cumulatively. Okay. But read the problem statement carefully to identify the error function. Okay. Here, the error is addition of all error is minus 0.24. How do you update W naught as per your gradient descent approach? How do you update W1 as per your gradient descent? W2 as per your gradient descent? What is the formula? What is the formula? See here, theta, okay. This is the formula, right? Old minus learning rate divided by this loss. I'm going to differentiate the loss function. Yes or no? Right? Into xi, right? Into xi. What is this xi? For W naught, xi will be, xi is nothing but x naught. For W1, xi will be x1. For W2, xi will be x2. Our case, x naught is always, we should keep 1, 1, 1 only, right? For x1, use the diastolic pressure, and for x2, use the BMI. Yes, that is what done here. That is what done here. Yes. So for W naught update, simply do this prediction. I'm just doing step by step. Compute the required sum alone. This is what my x naught, always 1. Okay. Sum of all errors into 1, you will be getting minus 0.24. For x1, how do you do it? First error into x1 is 35. Second error, the second record input is 25 plus third error, the third record error is 30, and add all together. This portion is minus 11.65. And for weight update W2, the sum is into 2. Take a second record. This is BMI. This is BMI. Okay. This is, okay. Here they used X1 as BMI. Sorry. X1 as BMI and X2 as diastolic pressure. Diastolic pressure. Simplify this. Now you can apply the weight update. Old new value, new weight is old weight minus alpha, right? Alpha into, that is 1 by n. What is alpha by n? To get the mean value, 1 by n, alpha into 1 by n, right? And the summation of errors, right? So alpha by n is, alpha is 0.02 divided by 3 records, you'll be getting 0.00667. And for W naught weight, you just consider the previous value, which is nothing but minus 0. See, 5 minus, old weight is 5, minus this alpha by n is this portion, and the summation part is minus 0.24. Simplify this, the new weight is 5.016. Update the weight for BMI, old weight, substitute everything, simplify this, new weight is 0.04, right? And for diastolic, the updated weight is 0.1793. For the second iteration, the gradient descent uses the updated new weight value to compute the next residuals or next predictions. Okay. Keep on do the same process again and again until you reaches your convergence. That is, until you reaches your loss should be minimal, right? This is a gradient descent approach, which requires multiple iteration, but it's not an iterative process. It's a non-iterative process. If you have very minimal data set, you can go ahead with the closed form solution. If you have a large data set, you can use the gradient descent. And one more important thing is selection of learning rate, that we will discuss in the next class. Selection of learning rate, it should not be too low. It should not be too high. We will discuss. Okay. Yes. this works well in large data set. It can support incremental learning. But here we don't need to consider any alpha selection. If your data set is large, then the computation will be very slow because we are supposed to compute this. Roughly the time taken will be order of n cube. That is the difference between closed form and gradient descent. In the next class, I'll explain about the different types of gradient descent, and then that's a concept behind this alpha learning rate. If you are using the minimal learning rate, what will happen? If you are using maximum learning rate, what will happen and all. Okay. Try to solve those both the problems using pen and paper. If you have any queries, even in between, within a week, you can also send me your solution. I will correct you. Okay. So it's sorry, it's 12:40. Sorry. Yes, if you. Yes. What's your query? Yeah, in some book they will use eta. Both eta and alpha is same. Yes, you can speak now.
Yes, ma'am. Can you go back to the slide 28? 28, ma'am.
This one?
Yeah. Here I
Oh.
didn't understood why the square can be written as two terms, but here one is transposed and one
Yes,
is
yes.
without
Yes,
transpose.
yes, it's a vector representation. If you want, I can annotate and I'll add one more slide here because it's a mathematical proof. It's a mathematical proof. Finally, we need you should know only this portion for closed form solution. Okay?
Yeah, okay, ma'am.
Yes, but
And can
if you
yeah,
want,
and can
I can do it. It will take time. But
yeah, okay,
for
ma'am.
understanding purpose with respect to our course, you just try to understand for closed form solution, this using this formula, you can get the thetas. Okay.
Ma'am, can
Okay.
you add it while uploading the PPT? At least we'll go
Not
through it
today.
on.
Yes, yes, yes. Not today, but damn sure I'll upload. I'll
Yeah,
add
yeah,
one screenshot.
that would be
Yeah.
suffice. Ma'am.
Yes,
Yeah.
yes.
You
For
can
sure.
upload it as a separate file itself.
Separate file.
That
Yes,
will,
yes.
yeah,
I'll
that would
upload
be
my
fine.
annotated. I mean, not annotated, written work. Okay. Later. Give me
And
Yes,
two
can
ma'am.
days
you
of
Thank
time.
you.
suggest one textbook, ma'am,
Sorry.
for this? Can you suggest one textbook which we can
Ma'am,
refer
could you please share the
so we will understand?
any book recommend for ML, ma'am?
Your
Yeah.
textbook is as per handout. It's Tom and Mitchell, right?
Ma'am, can you please type here the author name, please?
In the course handout, it's there, right? Go and download the course handout. There they have listed some references and textbook. Are you able to see the course handout in the Taxila page?
What's
Yes,
Yes.
the
ma'am.
what's the author
We
name you
refer.
said? Tom?
Tom Mitchell. 1 second,
Uh,
let me check.
Ma'am, can you go to next slide, please, ma'am? Where you have written theta 0 and theta 1.
This one?
Yes, ma'am. That last theta 1 1. I mean,
Value.
I didn't get that
1 1.
0 and
This one. Are you talking about this one?
yeah. I mean, how are we getting? I mean, theta is a. I mean, uh, it is the based on the formula. It will be one value, right? How two value? I'm not getting
No,
that.
that is what the base itself. You are not able to get the point.
It's a vector.
It's a vector. See, no. Your question is, I have only one input, but why I am getting two theta values? Yes.
Yes, ma'am.
No. See, in the line
That I
equation
understood. We
itself,
need a bias and
that is what I told you. This is theta naught. This is theta 1. Theta naught is bias value, constant value. This theta 1 is associated with years of experience. After getting this theta, your prediction equation will be salary is equal to, right? 1
no,
into
that I got, ma'am.
1 into experience. Yes.
But based on that x and y, x that matrix 1 1 1 1 and 1 to 2 rows and y is one column, right? So based on that, how are we getting that 1 1? That I didn't get, ma'am.
This 1 1 1. Okay. See, the thing is, initially you will be having only x1 column alone. Yes.
Yes, ma'am.
Yes. So, but as per our formula, the hypothesis formula, theta naught xi or xj. Yes, summation of theta naught xj, I is equal to 0 to j. How do you expand this? Theta naught x naught plus theta naught x1 plus, if you have d dimension or j dimension, theta j xj. Yes, in this case, it will stop up to this. Yes or no for our data?
Yeah.
Yes, we know theta naught is bias, theta 1 is coefficient associated with respect to experience, that we know. What about this x naught? How do you get it? Do you
We
have,
have
we can't give the random value here, yes? We should maintain as per my formula, y is equal to theta naught plus theta 1 x1. This theta naught should not be changed. How I can fix the x naught value? If you keep all 1, 1, 1, 1, 1, 1, 1, whatever theta naught is we are getting, 1 into 1, you will be getting 1. Whatever you are getting theta naught, then it will be multiplied with 1. That is why for simplification and for using some mathematical tricks, I'm just using the mathematical tricks to retain this equation. Understood?
okay.
For all data set, not only for this data set, even in your if you are implementing using Python, internally it considers x naught as 1 by default. If you have 100 records, 101 value will be there. Got it?
Okay.
Ma'am, I have a question from slide number 19.
I have another class. Yes.
This there's a sine wave. I thought it's slide number 19. Yeah, this one. So here you said that theta is not an angle but a parameter. So are we saying that because on the x-axis we have theta as a model parameter, on the y-axis is j theta cost function?
Yes.
Okay.
We are
Can we
trying
say
to
that
differentiate. Sorry?
Can we say that theta is both like an angle also and a model parameter
Yes.
also?
Actually, mathematically, if you are solving this mathematically, it should be taking angle only. Parallelly, we have to draw a line and take an angle. So the steps, that is, how do I know whether I should walk through in this direction or this direction? For that, we need angle, right?
Yeah.
Yeah. Don't worry. We will discuss the same topic in the upcoming class using the learning rate. I'll take the
Okay.
same type of slide only.
Okay, thank you.
Okay, thank you all. By 1:30, I have another class. Yes, Tom Mitchell is your textbook.
Thank you, ma'am.
Yeah, thank you all.
Please end the meeting
you.
because
Thank you,
some
ma'am.
folks don't leave the meeting and it delays the recording.
Yes,
Thank you.
thank you. Yeah.
Thank you.
Everyone, please leave. See, even though I ended the meeting, if you have to leave, then only you will get the recordings.
I understand. No, there's an option to end from the organization's perspective.
No, I have
So-
end meeting, but you will not get it. I have to remove every participant. It's already 56. No way. Please leave all.
Okay. Thank you, ma'am.
Yes, thank you all.
Thank you, ma'am.
Yeah, bye.
Thank you, ma'am.